yesterday we talked about the Pythagorean Theorem, and we wrote this stuff down. If you need to write it down again, feel free, but if you don't, I understand, because we worked with it a little bit yesterday. The Pythagorean Theorem says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. Leg squared plus leg squared equals hypotenuse squared. The key to these is to find out which is the hypotenuse and make sure that it is on one side of the equal sign and your squares of your legs is on the other side of the equal sign. Okay? So, the reason that we liked some of those problems that we worked with yesterday better than others was they came out as perfect square roots when we pulled them out when we used our calculator. And we didn't have to make a cake, or we didn't have to use a factor tree or look for perfect squares. Those things are called Pythagorean triples. Okay? A Pythagorean triple is a set of three positive integers, counting numbers, not fractions, not decimals, a, b, and c, that work in c squared equals a squared plus b squared, that work in the Pythagorean theorem. So a Pythagorean triple means that we have two legs and a hypotenuse that are all perfect squares. When we work them out, we don't get any radicals that have to be simplified and leave something inside. Does that make sense to everyone? Okay. One of them that we worked with yesterday was the very first problem in our assignment. Does anyone remember what the hypotenuse was on that one? 5. Because 3 squared plus 4 squared was equal to 5 squared. Okay? That's called a Pythagorean triple. We didn't get a decimal. We didn't have to leave anything in the radical. So, guess what? We can disguise those Pythagorean triples. This is the basic one, right? But if I have a 3, 4, 5, what do you think the next one will be? 6, 8, 10. Why 10, Jaden? Good. We just doubled them, didn't we? We doubled 3 to get 6. We took 4 times 2 to get 8. So 5 times 2 is 10. Okay? So if the next one is 9 and 12, we'll have 15. Because 3 times 3 gave me 9. 4 times 3 got 12. So 5 times 3 is 15. And 3 times 4 is 12. 4 times 4 is 16. So 5 times 4 is 20. If you can recognize these triples, it can save you a lot of work. Okay? Anytime you see 3 and 4 as legs of a right triangle, you know the hypotenuse has to be a 5. If you see 9 and 12 as 2 legs, the hypotenuse has to be 15. If you see the hypotenuse of a right triangle as 20 and one of the legs is 16, the other leg has to be 12. So it can save you some work. Make sense? Okay, so let's look at the next one. 5, 12. Anybody know what the third part would be? Off the top of your head? No? Let's work it out. 5 squared is 12 squared is, and 44 plus 25 is 169. What's the square root of 169? It's 13. So 5, 12, 13 is another Pythagorean triple. And therefore, 10, 24, 26 will be one, 15, 36, 39 will be another, and 20, 48, 52 will be a third. Okay. And we could multiply everybody by 10. 30, 40, 50, right? Okay. So now 8, 15. Here's another one. 64 and 289. 64 and 225 is 289. What's the square root of 289? Nope. 17. Okay, so 8, 15, 17 is another one to be aware of, because they're going to help save you some time. And therefore 16, 30, and 34 will be another. 24, 45, and 51 and 32, 60, and make sense? Okay, last one of the common Pythagorean triples. 7, 24, so 49, and what's 24 squared? So 49 plus 576 is what? And 625 is a perfect square. The square root of 625 is 25. Got some major computational skills in people's brains in here. That's good. Okay, so 14, 48, and 21, 72, and then finally 28, 96, and so all are Pythagorean triples. They're ones to be aware of. Doesn't hurt to have them written down. You can look for them, recognize them, notice them. Okay, makes sense? What questions do you have on this slide? All right, so here we go. Find the value of x and decide whether the links form a Pythagorean triple. So the first step in any of these problems is always to figure out which is your hypotenuse. So what's my hypotenuse? X. X squared has to be by itself. And the legs squared will be on the other side of the equation. So 4 squared plus 5 squared, or 5 squared plus 4 squared. The order of the adding of the sum of the squares of the legs doesn't matter. So 4 squared is, and 5 squared is, so 16 plus 25 is, and in x squared is now 41. So how do we make the x be a plain old x to the first power? Opposite of squaring is square root. So if we square root both sides of the equation, we get lazy in geometry because we're only talking about sides that are positive, right? But there would be a plus or minus the square root of 41. In geometry, that negative doesn't make sense. So we just say plain old square root of 41. Is there a perfect square in 41? Probably not, right? We know it's not a perfect square, right? So is this a Pythagorean triple? Nope, not a Pythagorean triple. Okay, not on our list of perfect squares. 6 squared was 36, 7 squared was 49, right? It's between those two. It's not a perfect square. Make sense? Questions on this one? Camera, put it away, please, sir. Okay. How about this one? Which one's the hypotenuse? 25. So 25 squared will have to be equal to, it has to be all by itself, the leg squared plus the other leg squared. So 25 we said was squared was 625. And 15 squared is 225. Works great if you're a human calculator, but hopefully you've got your calculators out to keep up with us. So 400 is x squared. We want to get rid of the squared, so we square root. What's the square root of 400? Positive or negative 20, but in this case we only want the positive, so x is 20. Is it a Pythagorean triple? Everyone see why? Came out of the calculator nice and neat. Okay. Already wrote that, so yes, it's a Pythagorean triple. Okay, any questions on these? Yes, sir. Yes, that's fine. Okay. All right, you've shown me all that work. Yes, this is perfect. You've justified your answer. Okay, so here's a flagpole, and it's being supported by two guy wires. So maybe the footings aren't deep enough, maybe this concrete hasn't set yet, right? So they have some guy wires that are, or some support wires that are holding that flagpole in place, okay? We want to use the Pythagorean theorem to approximate the length of each wire. When they say approximate, that's a key that says go ahead and take the square root, use decimals, okay? Yes, sir. Absolutely, we can just use one. We don't have to use both. We have a big, giant isosceles triangle here, right? Each of these is x, and the 15.1 is the altitude, right? The vertical support. And so we're going to figure out which is the hypotenuse, the x, that has to stay by itself. And then we use our two legs squared, so 8.5 squared and 15.1 squared. Okay, so now we break out our calculator. And you all know how to use your calculators, right? All right, so we want to take 8.5 and square it. So you should have a squared button somewhere. We add on the 15.1 squared. Okay, and we get a total of 300.26. So if x squared is 300.26, we want to take the square root, right? So you shouldn't have to retype these things in. Most of your calculators are going to have an answer button. Okay, so start using it. It'll save you time. So we want to do a square root. The square root is the shift or the second of my squared button. So square root of, and then answer, second answer. And we get 17.3. Okay, so x is 17.3. Everything else was 1 decimal point, so we'll call it 1 decimal point. And it will be in feet for our unit. Okay? Questions on this one? All right, so here comes the next. Converse of the Pythagorean theorem holds. Okay, it said that if it's the Pythagorean theorem says if you have a right triangle, the leg squared plus the leg squared is the hypotenuse squared. The converse switches them, and it says, hey, if a squared plus b squared equals c squared, then it's a right triangle. Okay, so let's try this out. They will give you some triangles, and they will say decide whether it's a right triangle or not. There's no right angle here, right? So which of those three sides in that first triangle appears to be the longest, Jaden? In the first triangle. 12, okay? And we can verify that by saying, hey, tell me what is 4 times the square root of 5? 4 square roots of 5 is 8.494. Okay, definitely not the longest. 12 is the longest. Okay, so we want our 12 squared to be by itself. And we're checking to see, is it equal to 8 squared plus 4 square roots of 5 squared? Okay, so Austin, what's 8 squared? And what's 12 squared? So we want to check, is 144 equal to 64 plus, now here's the tougher one. How do we square 4 square roots of 5? 4 times itself, right? And then what's the square root of 5 squared? It just makes the squaring a square root makes the radical disappear, right? So we will have 16 times 5. Does everyone see why? Okay. So does 144 equal 64 plus 80? Yes. So yes, it is a right triangle. Okay. Thank you. Okay. All right, next one. Now we look at this guy and we try to decide which of these is the longest side. Okay, looks like it might be 14, right? If we're not sure, we can take 2 times the square root of 30, right? The square root of 30 is going to be 5 point something. The square root of 25 is 5. The square root of 36 is 6. 5 point something times 2 is 10-ish, right? So this is the smaller side. This would be a leg if it's a right triangle. So is 9 squared plus 2 square roots of 30 squared equal to 14 squared? So what's 14 squared? So 196, is that equal to 81 plus 30 times 4, right? We square the 2 and remove the radical. So 4 times 30 is 120, right? 120 plus 81. Sorry. 120 plus 81 is 201. Does 201 equal 196? I switched them. Transposing numbers. Thank you. Are they equal? No. So is it a right triangle? No. Okay. Questions on this one? All right, so here comes the last piece. The last part says that if you compare the square of the longest side with the sum of the squares of the other two sides, and those two, the sum of the squares is bigger than the third side squared, the largest side squared, the triangle ends up being acute, less than 90 degrees. All angles less than 90 degrees. But if you compare them and the longest side squared is bigger than the sum of the squares of the other two, then it's an obtuse triangle. Okay? Make sense, everyone? So when we have a big giant opening, that makes my c squared bigger than a squared plus b squared. But if I have a smaller opening, smaller than 90, then my c squared is going to be smaller than the sum of the a squared plus b squared. So let's look back at this last problem. My biggest side squared was smaller than my sum of my other two sides, right? So was this acute or obtuse? Does everyone see why it's acute? Because my third side squared is smaller than the sum of the other two. Okay? So you'll have problems like that today too. All right, so here comes your assignment.